Hey guys! So today you and I are going to talk about important features. So let's get into it. So the question in question was, hi Frederick, what would you say is the most important feature of scalable software? I would say that it is modularity. I would say that is the most important feature. Now that's not necessarily a feature in the sense that we talk about like user features or something like that, but it's more about the design of the system, because the thing that I argue is, which is my way of putting it at the very least, is that the hardest problem in software is not naming or caching. The hardest problem in software is maintaining quality over time, or managing complexity over time. That is the hardest problem. The reason why I argue that is because basically the way that it works is that when you start off with a simple solution or a simple system, things are usually very effective in terms of how fast you can ship and meeting expectations and all that good stuff, right? But because a software code base doesn't work, as I like to say, like a regular product in the marketplace, because if you buy a product, the process of developing that thing and then shipping it is a finite, it's a final step in the chain. You ship the thing, and assuming now that it meets market requirements and you don't have to do recalls, when you want to build another thing, you start again with the learning you took from the first thing, and then you redesign from scratch more or less again. I mean, people are reusing components, but I hope that you sort of get my point. But when it comes to software, it's always connected. And you don't just start off with a new project every single time. You just keep on adding and adding and adding and adding. And if you don't think about it too much, you will find that the code base becomes what we call legacy, or like really, really messy, and the system becomes really, really wonky and weird and so forth because of the inherent realities that we face. And that's why I argue that every software developer who's ever had that epiphany or like had that realization where someone comes in and looks at their code base, because you get blind to it yourself if you work on the same system for long enough. And when you realize that when someone fresh comes to the project and they look at your project, what they see is just a big, it's almost like a tree, I argue. It starts with a simple trunk, and then it goes off into branches, and like new features are added, features should overlap with each other, you have to do hacks and compromises and stuff like that, and they just look at this gigantic mess of a tree that has like branches going all over the place, right? And because you are blind to it, because you've been working on the software in question for long enough, you've sort of learned how it all works. And if you are one of those software developers who were there from the first, you start, like, the thing, at least that I realized, is that because you're on the journey all the way, you get one perspective of the code if you're there from the beginning and travel along until it gets to this state. But you get a completely different perspective, the thing we say, take a step back. And if you look at something with fresh eye, that is the real problem. And that's what you usually find in software these days, where you have key people or systems around the globe who are really, really working. Features are working in some way, you don't know why, nobody knows. The people who used to do it, they are not there anymore, like all these sort of things, right? And so that's the problem with scaling, because that problem doesn't exist at small scale. It usually only exists at very large scale, or like when the problem is already like so severe that it's hard for anybody to do anything about it. And that's what really big companies realize when they have built a business model, and then there's like a little startup who comes in and disrupts because they have a more efficient way of doing the thing that they are doing. And software works the same way. And so that's the most important feature. And the way that I argue that you achieve modular code or scalable software is to using what I use, like basically to take a page from the way that operating systems are working or anything like that, where if you think about it as a kernel and modules that are loaded by the bootloader, or like the loader, then what basically happens is that you have all these various modules that needs to connect to like the startup process, and the process just goes through and loads them all up. And I argue that the way that you do that in our case of web development is with a modular monolith. Some people have gone to the point of using microservices for stuff, but that's a different sort of problem. And the thing that I argue for is that if you truly want a sustainable system, you should look at systems that have mastered modularity. How is it possible to reach encapsulation and isolate complexity of something to one, like to mitigate the blast zone, so to speak? Because if you think about it, as an example, if the feature that you're working on, and this is what happens usually, if that feature is developed at one point and then not necessarily needed, then you never use it again. But if you write the code in such a way that the next thing you need to work on is going to be impacted by the thing you wrote, then all of a sudden you basically, it has sort of seeped into the rest of the code. And that is what happens on average if you don't design your system in a modular fashion, because everything that you add or change or like, and I truly despise when developers say, oh, like managers are giving us these weird expectations, and so some scopes are changing all across the board, and I kind of go, yes, that's business. It's literally how business works. I promise you, if everybody in the business world knew how to perfectly design all the requirements so that we developers can build a perfect system, they would, but they don't. And so the thing that I argue for is that as someone who has mastered software, or like the craft of software, you should account for the fact that some features are going to be developed with one set of assumptions, and then it's going to change. And then it's going to do something else, and then like a third thing is going to come in. It's a chaotic environment, and the best way to deal with such a chaotic environment is to make sure that every time you sit down and you write a new feature, whatever you're doing, make sure that it's easy to add it and just as easy to remove it without impacting anything else in the code base. I argue that if you think about operating systems, or like the Linux kernel, like the Linux operating system, for example, it works very much that way. There's so many different modules and different hardware on the market, then they fit into that structure. Same thing goes for your package managers. If you think about NPMs, like the package manager for that, or NuGet, or Maven repositories and stuff like that, you have thousands and thousands and thousands of libraries with all kinds of functionalities added to a gigantic repository, and the dependency graph is still going to work for them. And I think that if you structure, like, that's the thing I don't see in regular software developers' minds. Like, I see that in library authors, they're amazing at this stuff, and the people who really understand this, they are really, really good at it, I argue. And I think you should do the same thing in your own code. Start treating your domain entities if you're doing backend, for example. My favorite slicing part is that, okay, the thing that you would have made a microservice of, just make a folder. And think about, okay, if this was a package that I was going to submit to a repository somewhere, and all it's going to do is a bunch of business logic and stuff like that, then the only thing you really have to expose from that thing is the controller, for example. If you're in front-end land, well, instead of just adding all your components to one big components folder, create a folder named after the damn component, add your tests inside of there, and add all the subcomponents and so forth, like achieve encapsulation at the folder level, and then your code base is literally just a big source folder with a bunch of components that in isolation, if you just put an npm file into any of those folders, you could have published it to to npm or Yarn, like with Yarn or whatever you're using, right? Same deal. If you approach it the same way as library authors do, you do get more of this, because as I said, if you can achieve this, then it's the safest state for you to be in order to make sure that your system can scale forever. So what I want you to take away from this is that the most important feature of scalable software, if you ask me at the very least, is modularity, or as I like to say, writing disposable code. The reason why I argue for that is because you can't know the future. All you know is that if you're not careful, stuff that you do today might have a really shitty impact on stuff that's going to happen tomorrow, or in 10 years, or in 20 years. It's kind of hard to say. So what I argue would be the best position to be in is in a state where you can do the thing you do right now, and you make sure that it does exactly what it's supposed to do and it fits nicely into the current system. But it's also a very easy thing to change it or completely remove it without impacting other things that are going to happen or are happening in parallel. That is what true modularity is. Basically like a Lego system. You should be able to put in a brick and remove it. But if you have that problem, as I said, where if you put in one brick, you're stuck with that brick forever, you can never change it again. Now it is affecting the rest of the lifespan of your system. And that is the thing that I argue software developers have to master in order to do things efficiently. I'm not saying that it's always going to be easy, but I'm saying that it is probably one of, if not the most important things that you can learn how to do. And in my opinion, the thing that I have taken the most learning from is package management systems, like how they store different libraries that we depend on as third-party dependencies, stuff like that, modular monoliths, and to some extent as well, of course, microservices and so forth. Like this idea of controlling how much of a feature or an endpoint or visual component, whatever you're creating, to create it so that it is isolated to just the value that it brings without leaking into the whole code base. Because I see a lot of people these days, and that is the norm, that the scope of your code base is literally, there's a source folder and there everything lives in there, and you don't slice it up into smaller segments often, because you basically treat your entire application as one gigantic package instead of just a application that has a lot of smaller modules. And that's the thing that I argue the operating system does really, really well, where there's 100 different types of modules that you can load into your operating system, and each of them work if you want to plug them in or if you want to plug them out. It doesn't affect the rest of the thing, right? And that's this architecture that you should go for. It should be easy to add and it should be easy to remove. That is a very good way of doing it, I argue. Have a great day.